everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communication Engineering at MLR Institute of Technology. So today I'm going to explain the timers and counters unit present in the 8051 microcontroller. So the overview of today's presentation is timers and counters and how many different timer registers are there in and what is the main difference between the timer and counter and what are the special function registers present in the timers and counters unit, which is TMOD, timer mode register, and TCON, timer control register. So this video is a part of series microprocessors and microcontrollers. If you want to know what is the microcontroller, and do watch the previous videos. So coming to the timers and counters. So if we want to provide any time delays in the program, or if you want to count the number of operations that done in the external part, or how many times that loop has executed, like that. So we will be using this timer and counter unit present in the 8051 microcontroller. So now what is the why we are using timer and counters in 8051? So let us see. So a timer, actually in the 8051 one unit is there. That unit can be operated as a timer and can be operated as a counter. So if we want to select that particular unit as a timer, so we need to switch one single bit present in the TMOD register. So it will be explained at that particular register. Okay. Now what is the purpose of having timer and what will be counter to? Let's see. So a timer measures the intervals by counting either up or down. So like a stopwatch, okay, it will be count up or it will be count down. So it is used to generate time delays in electronic systems. Okay, yes, and suppose in microwaves, or in now we are using every electronic gadget at our home, right? So and the examples of timers is hourglass. So it will be calculating up and down like that. So then what is the counter? So counter keeps track of how many times the external events occurs. Okay, so it works like a clock signal to count external intervals, or you can say it to count the clocks, number of clock pulses. Like so, it is implemented using flip-flops in the digital electronics, right? So the main difference between the timers and counters, the input source for the timers is the internal clock. It uses the internal clock of the microcontroller. Okay, the counter is external pulses. It always depends upon the external pulses or the number of events happening external. So the function of this timer is to provide time delays or time intervals, and the function of counters is to count the external events or the external pulses, right? Yeah. If the in TMOD register there is one bit, that is C by T bar. If C by T bar is equals to 0, the unit acts as the timer. Okay, if C by T bar is equals to 1, the unit acts as the counter, right? Yeah. So increment operation, how increment operations work? Increment operations work for every machine cycle. So how many clock cycles are required for one machine cycle? In 8051, so 12 clock cycles are required to provide one machine cycle. Here the increments will always fall from the edge. So falling edge or external pulse, both of them are used to increment, right? Yes. Use case, so where we can use this? So timers are specifically used to provide delays and time measurements, while coming to the counters, it is used for number of events, count of the events or pulses. So how many clock cycles or how many clock pulses are required to perform this particular operation, like that. Yeah, this is the main difference between the timers and counters. So now see, in timers, the 8051 is having two timers, timer 0 and timer 1. So though microcontroller 8051 is a 8-bit microcontroller, but it is having two timers, each of having 16-bit width. So the both of them are 16-bit, timer 0 and timer 1, both of them are 16-bit wide. Since 8051 8-bit architecture, it supports 16-bit of timers. So the remaining else are DPTR. Apart from DPTR and these two registers, everything will be in the 8-bit registers. So here timer 0 register, though timer 0 is a 16-bit, you can use it as a higher 16-bit, lower 16-bit as a both individual timers also, in particular in one mode of operation. So this is the 16-bit register timer 0. So the lower 8 bits can be used as TL0. So the timer 0 lower byte, and this is can be used as timer 0 higher byte. So from D0 to D7 bits will be used for the lower, and from D8 to D15 bits they both they are used for the higher bit. So here, so how to use, this is one of the example how we are loading. So here we are loading the data immediate value 04H into the TL register. So here what it will become, so 0 means 0000, and 4 how we will represent 0100. So this is the value after executing this particular instruction in T timer 0 register. Okay, so here we are mentioning TL0 means in timer 0 lower byte. If it is TH0, so in timer 0 higher byte. So likewise, the timer 1 register is also there. So the timer 1 register also follows the same method. So here it is also 16-bit timer. It could be divided into two 8-bit registers. Here we will mention it as TL1 and TH1. Here 1 represents it is a timer 1, and TL represents it is a lower byte, and H represents it is a higher byte. Right? Yes. So when TL1 overflow, so what is overflow? So there is one condition in timers that if the maximum size of the timer has been completed and another operation is going on, so what it will become? So see, if the timer is of 16-bit register, right? So the highest, the maximum size is 4Fs. So the minimum is 4Fs. If after getting to the highest location also, if the timer again has another event to execute, so now it will roll back to the original, the smallest. So when we are using counters also, if the if 10-bit counter is there, so it will calculate until 10, then next it will get back to the 0 location, 0th, right? So 0th count. Likewise, if it roll backs to the minimum size of that particular register, so such type is known as overflow. So how we will check the timers? We will always check the overflow bit. If that timer overflowed, so the delay already happened or the delay completed, like that we can say. Okay, so if the lower byte is overflowed, then the automatically higher byte will be increment. If both the 16 bits are overflowed, then we will get one intimation by using the bit present in TCON register that timer 1 has overflowed or timer 0 has overflowed. For both registers, they are having two separate bits in TCON register. We will be seeing what it will be. So the total in together, this timer 0 and timer 1 of 8051 can count from 0000 means 0 to FFFF, the highest value. So the value is 65,532. Okay, so this is the decimal conversion of the timers. So coming to the next one, here we are having two special timers. The first, two special registers, which is T mode register. It is also known as timer mode register. And the second one is TCON register. It is timer control register. So in T mode register, we can select which timer, we can set which timer is going to act. So either timer or counter, you can select both the operations at a time, only single one operation. So and it is having 4 modes of operation: mode 0, mode 1, mode 2, mode 3. So in which timer is going to perform in which mode, so this will be selected by using the T mode register, timer mode register. And in TCON, so how to start the timers? To start the timers, there should be one bit. So here TR1 and TR0. To start timer 0, we will be using TR0. To start timer 1, we will be using TR1. And overflow bits, I have already told you, if it reaches the maximum size, it will roll back to the minimum size of its location. So there will be overflow flags. So if we need to check the timer flag of 0 timer and the timer flag of 1 timer, this along with these two, other 4 interrupt pins will be present in Tcon register. So finally the Tcon register is helped to control the timer operations, where Tmod is responsible to configure the timer and counter behavior. So Tmod also sets whether the timer is used as a timer internal clock or as a external clock pulses like counter. So both Tcon and Tmod must be configured correctly to use 8051 timers to generate time events or to generate delays, right? So here in Tmod register, so the lower timer 0 values will be a gate, C by T bar and M1 and M0. Here the gate bit. So if the gate bit is 0, when it want the timer to run independently of any external signals. Just start it with TRX equals to 0. If we want to start the timer 0, so just we will keep TR0 as 1. If we want timer 1, so we will keep TR1 as 1. Okay, so you can say that if we want to keep, if the gate bit is 0, so always the software will perform the timing operations. Like we will be writing one program, so software we will be utilizing. Most of the cases we will be keeping gate bit as 0. If gate bit is 1, then the control, the timer external control will be there. Yes, such as starting it with only when external devices sends high signal. That means INT 0 or INT 1 if timer 1, for INT 1 if timer 1, INT 0 if timer 0. So most of the cases we will be using gate as 0 only, right? Yes. So here in this one, the gate will be used for operating with the software or external. Next, C by T bar. If C by T bar bit is equals to 0, then this particular unit will be acts as the timer. If the C by T bar bit is equals to 1, then the particular unit will be used for the counters operation. And there is 4 modes of operation in Tmod register, in timers. So that modes will be controlled by using, that modes will be selected by using M1 and M0 bit in the Tmod register. So these will be used for timers 1 and these will be used for timer 0. So here coming to the gate bit, to select it with, so C by T bar. Here C by T bar means if it is equals to 0, timer mode will be on. If it is equals to 1, counter mode will be there. So M1 and M0 will be used to fetch the modes. So here we are having 4 modes in 8051 microcontroller. So 0, 0, 0, 1, 1, 0 and 1, 1. So if 0, 0 is there, then mode 0 will be selected. The timers or counters will be worked on mode 0. And if 0, 1 is there, the timers or counters work on mode 1. If 1, 0 is there, mode 2 will be selected. And 1, 1 is there, only timers will be worked in mode 3, not the counters. Okay, counter will only work in 3 modes. Right? So this is the modes of 8051 microcontroller. Mode 0 is 13-bit timer mode. So if we want to perform the operations, depends upon the just 8 to 12 bits. If 12 bits are there, so you can use this 13-bit timer. If mode 1, 16-bit timer, full-fledged, the 16 bits of each timer will be utilized in this mode. And mode 2, only 8-bit auto reload mode will be there. Most of the communication devices present in 8051 communication is of 8 bits. So in that particular communication device, to set the baud rate, so how much data will be transmitted in 1 second, like that. So to set the baud rate, we will be using this 8-bit auto reload mode. Most of the cases, 90%, 99% we will be using this only, and timer 1 will be used in that particular case. Okay, mode 3 is a split timer mode. Each individual timer 0, only timer 0 timer will be used here, not timer 1. Timer 1 stops, and timer 0 TL0 will be used as a separate 8-bit timer, and TH0 will be used as a separate 8-bit timer, right? Yeah, this is how we will be using these modes. So if now this is Tcon register, another special function register. This will be used to control the timer. So if timer 1, I need to start the timer 1. So this bit TR1 need to be 1. If I want to stop, it need to be 0. Like TR0 is the timer 0 bit. If I want to start this bit, I need to keep it as 1. If I need to stop the timer 0, I need to keep it as 0. Right? So TF1 and TF0 are the timer flag registers, overflow flag registers. If the timer 1 is overflowed, then this bit will help to identify that. If timer 0 overflowed, this bit is used to help, right? And the other part, lower 4 bits of this TCON register will help us to identify the interrupts. So here see, if IE1 is 1, so the external interrupt INT1 occurs. So we can identify by checking this interrupt pin that external interrupt has occurred. So cleared by the hardware. So if IE0 is there, so external INT0, external interrupt 0 occurred and it will be cleared by using the hardware. So IT1 and IT0, these both are be used for, if they both of 1, then edge triggered is there and cleared if 0 is there. So 0 is there and level triggered. Okay, this is for INT1 interrupt 1 and this is for INT0 interrupt 0, external interrupts. Okay, yeah. So until now I have discussed it. So what is a timer, what is a counter, so how we can use the same unit for timers and counters, and what are the main differences between the timers and counters, and the general registers of timers, timer 0 and timer 1, which is of 16-bit registers, and what are the two special function registers present in the timers, T-mode and T-con. So T-mode is used for the mode control and how to select the timers, and T-con is used for the timer control as well as interrupts also. So thank you.